let's get a little bit more practice with writing loops. So in this video, we're actually going to write a loop directly. We're not going to do it from the translation pipeline. But we're going to start off with a rather mild example. So let's say we want to write or design the count alphanumeric chars except method. So long name aside, all we're doing is we're going to count the number of alphanumeric characters in a string. So alphanumeric characters are letters and numbers, ignoring case. But there's one rule to this where we will ignore occurrences of the character C. Okay, so we're given the string, the character to ignore, and the number of characters in. So we return the number of alphanumeric characters in S, ignoring C. So we have some tests here. Again, always write your tests. And if I gave you this question on, let's say, a problem set or a lab or an exam, I would, of course, expect you to write all the test cases. Okay? But let's think about how to do this with a loop. So let's first open up our little Paint program. So let's say we have the string A1, B2, C3. Okay? So what are the valid indices of this string? Well, of course, it's 0 through 5, right? So we want a loop to go from, let's say, I equals 0 up to 5, okay? Another way to phrase this is actually to say I is equal to 0 up to, but excluding the length of the string. Okay, so there's a reason for this. So it depends on how you want to traverse over the loop. So let's say that we have a loop that goes from I equals 0 and then up to 5, up to and including 5. So that's the important part here, right? So if we were to include the length of the string, rather the index at the length of the string, we would be out of bounds, and that would not be good. So whenever we're using for loops, it's very common to have our iteration variable, let's just say I, be less than the length of our string. Okay? Of course, if you did less than or equal to, we'd run into that problem that I just erased here. Okay? So that's why we don't do less than or equal to. But the question is, what if you really care about less than or equal to? Well, you can do that. Just do less than or equal to the length minus 1. And then you get up to and including 6 minus 1, which is 5. Okay? But it's very idiomatic to always just do less than. You'll very rarely, if ever, see that, what I just erased, the minus 1. You'll very rarely see that in practice. Okay? And what we're going to do is we're going to check every single character in the string. Okay? So we're going to go, is this alphanumeric? Is this alphanumeric? Is this alphanumeric? Is this alphanumeric? Blah, 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 blah. At the same time, though, we're going to check to see, is this equal to C? If so, ignore it. If this is equal to C, if so, ignore it. Okay? So what we're going to do is we're going to have a loop from I equals 0 up to I is less than the length of S. Just assume this means the length of S. And then after every iteration, we're going to increment I by 1. Okay? So we're going to do I equals I plus 1. So after every iteration, we're going to go to the next character in the string. Now, one thing I will mention is this notion of what's called the augmented assignment operator. So rather than writing all this out, we could actually just write out I plus equals 1. And it'd mean the same thing. So we could do I minus equals 1, I times equals 5, I divide equals 100, I mod equals something. So the augmented assignment operator works for many different cases for many different things. So if you don't want to type out I equals I plus 1, you can do that. But there's one more shortcut that's very common to see. You might see I plus plus. So this is what's called the postfix increment operator. I cannot spell. I also can't write, but that's fine. You heard me say it. The postfix increment operator. So what does this do? This is the same thing as this. Okay? For all intents and purposes, this is the same thing. You might see something like plus plus I. You might see... so these two things, for most intents and purposes, are the same thing. If you use them in a for loop like this, they are the same thing. If you use them in other contexts, like the book shows, they may be different. And there is a very important distinction that I don't want to talk about in this video. Okay? There's also the decrement operator. So you have I minus minus and minus minus I. Again, these two, most of the time, are the same thing. If you use them in a for loop, they are the same thing. They just mean I equals I minus 1, for the most part. Okay? If you want to learn about that more, read the book. Okay? So, that's our loop. Let's get through the code. So, first thing we're going to do, we're going to have a counter. Okay. Sorry about that. I had to make a small cut. So the first thing we're going to do is we're going to create a variable for the count. Okay, so the count, of course, is just the accumulator for our method. It's going to start off at 0. And then the first thing we should probably do is just return the count. Okay, so we initialize it, we do some stuff in here, then we're going to return it. Okay, now what do we say our loop was? Our loop is going to be for int I equals 0, I is less than s dot length, I plus plus. Again, you can do I equals I plus 1 if you really want to, but I plus plus is very idiomatic, and you'll get used to it very quickly. Okay? So, now what are we going to do? So, the first thing we should probably do is check to see if the ith character is equal to C. And if so, we're going to ignore it. Okay? So, how do we do that? Well, we can get the ith character by just doing s.char at I. And I'm going to store it in a local variable because I don't want to have to keep typing out s.char at I. Okay? First thing, if ch is equal to c, then what do we want to do? We don't want to do anything, right? We don't want to increment a counter. We don't want to do anything. We just want to go to the next character. But the thing is, we could just leave this if statement blank. That would be fine. But it's not very idiomatic. What we could do is use something called the continue keyword. Now, even IntelliJ is going to say that this is unnecessary, but that's fine. What the continue keyword will do is it will jump back up to the top of the for loop. Whenever we see the continue keyword, all it does is we just take it, then we jump back up to the top. Okay? An analogous keyword is the break keyword. As soon as we see a break, we jump down to the bottom of the loop. Okay? Now it should be noted that continue will still run this stepper expression. Okay? So no matter, like, if we have the continue keyword, we're still going to run this expression. Okay? So this doesn't get affected by the continue keyword. This does get affected by the break keyword, but of course it does, and it doesn't really matter because we're just breaking out of the loop anyway. Okay? So, if ch equals c, then we don't care, go to the next character. Okay? What about when the ch is a letter? Well, we can test that. So character dot is letter. We can pass it ch. So if the ith character is a letter, then we're going to increment count. Okay? But what about if it's a number? Then we can just combine these two cases. So, if character is digit, then we'll do the same thing. We'll just increment count. Okay? Now, if it's anything else, we can just continue. But again, this is not very idiomatic. And really, neither is this. So, I'm normally not a fan of what's called the one-armed if statement, which is where we just have an if and that's it. But in this case, it's fine. So what we can do is just collapse all of these into this, because we only have one case where we really care about anything. If it's not a letter and it's not a digit, then it doesn't really matter. So actually, this is kind of a poorly stated problem. Now that I'm, well, actually, no, that's not correct. I'm sorry. This is, yeah, that's not right. So, well, actually, we could collapse this into one thing, and let's try to do that. So, the thing is, we need to make sure that it's either a letter or a digit, and it's not equal to C. For some reason, my brain was like, my brain wasn't considering that C could be alphanumeric. So, but what if it is, right? Like, for example, if this is, let's go to our test here. If our character is C, the uppercase C, then that's alphanumeric, right? But we can't count it. So what we can do is say, if it's alphanumeric, and it's equal to, if it's not equal to C, then we can count it. Okay? So CH does not equal C, and this whole thing is true. So remember that we have to, well, not remember, but we have to put this in parentheses because this must be true and this must be true. It must not equal the string, the character to ignore, and it must be alphanumeric. And if it passes both of those, then we can count it. Okay? So we do all that, then we return, and all of our tests should pass. And they do.